Good morning, Tehmina Khan is here in TKMaths is Fun. In today's video, we will continue studying the lesson on friction, which is a part of the syllabus of A-Level Mathematics M1. We have seen the explanation with the help of examples in the earlier video, and in this video, we will focus on the past paper question. This is second question on the topic, and next videos will be on the work power and energy. So let's start this question. First of all, we will highlight the key points or key information from the question. So blocks P and Q of mass m kg and 5 kg respectively are attached. So this is mass m kg and this is 5 kg. So all the forces we will show on the diagram first before solving the question. The string passes over a smooth pulley which is fixed at the top of the rough inclined plane. So plane is rough and the angle is 35 degrees to the horizontal. Block P is at rest on the plane and block Q is hanging vertically below the pulley. The coefficient of friction between the block and the plane is 0.2, and we know coefficient of friction is represented by the symbol mu and it is 0.2. It has no unit. Find the set of values for m which the two blocks remain at rest, for which the two blocks remain at rest. So we know, first of all, you think what does it mean if you can understand. There are two possibilities in which the block will remain on rest. Very lightweight. What is the lightest weight so that it doesn't go up? And what is the heaviest weight so that it doesn't slide down? When it will be very heavy, I can say it is about to slide down. And when it is very light, it is about to. Why I am using the word about? Because it will remain at rest. This is what the requirement of the question. So these are the two extreme ends of the weight, and this is what we have to find out. Okay, between these weight, if the mass of P will be, it will not move. This is the meaning of the question. So we have to solve considering these two equations. Why considering these two equations? Let's see. First of all, in the given diagram, the tension is acting upward in both the cases here. Here the force is 5g and g I will take 10 meter per second square, right? Because in the exam of 9709, g is instructed to take 10. Now, the case when the object is very light and it is about to move up, the frictional force will be acting downward. Okay, so if frictional force is acting downward, it means object is about to move up, because frictional force is always in the direction opposite to the motion. But when the object is very heavy and about to move up, frictional force, maximum force will be acting upward, and we know maximum frictional force is represented by mu r. In both the cases, we have to keep the resolved forces of the weight. And how to resolve forces we have seen in the previous videos, so I'm resolving it here. The link of all the videos in the playlist is given below in the description, so if you want to see that, you can click the link. So this will be 5 mg. Weight is mg. Okay, so this will be mg cos 35 mg sin 35. So this is acting downward always, the weight. Okay, and one more thing, which is normal reaction, the force. So the equation which will be made for these two conditions, we will solve here one by one. So let's consider the first case. So first of all, I'm talking about the case when object is very heavy and it is about to move down or slide down. So diagram will be like this. Why did I write here? Because object is about to move down, frictional force is acting upward, tension is acting upward, parallel to the plane. These two forces are acting upward, and due to weight, it is acting downward. So this is what I have written. T plus mu r is equals to mg sin 35. Now we have to substitute the value. If you look at Q, T is equals to 5g. right? If you look here, t is equals to 5g and 5 is g is 10, so it will be 50. Mu is 0.2. Now what is r? R is force vertical to the plane, and the only force vertical to the plane is mg cos 35. So I will write here mg cos 35, and this will remain same. Because we have to find mass, so I will take this term to this side and take m common factor out. So now pick up the calculator and calculate m. Let me do it. Okay, so I'm getting 12.2 and unit will be kg. Now let's consider the second case, when object is very light and it is about to move up. Now you can see here, because object is about to move up, the frictional force will be acting downward. Maximum frictional force. Now maximum frictional force and the force due to weight parallel to the plane are acting downward, and force due to tension is acting upward. So that's why the equation will be T is equals to mu r plus mg sine 35. Now again we will substitute the values here. T we already know is 50, we have seen. Mu is 0.2 and r is mg cos 35. Now you pick up the calculator. I think you understand what I'm doing here. Manipulation. 50 divided by 0.2 g cos 35 plus g sine 35 is equals to m. Exactly this what I did earlier also. So the value of m, let me calculate. .78. So the requirement of the question was, find the set of values for which the two blocks remain at rest. So now you can say the mass should be in between 6.78 to 12.20, right? If the mass will be this, object will remain at rest, it will not move. So I hope you understood. Please press like and subscribe button and share it with your friends, and do write comments if you have any query, or also if you like the video, if you have learned something, your comments will be appreciated. Thank you so much. Take care. Allah Hafiz.